If we try to build a loop device that can be turned on and off using only logic gates and no other loop control components, it won't operate correctly in reality. To demonstrate this, I'll run an experiment. We can use any kind of logic gate, but here I'll use an XOR gate. To make the circuit loop only when B is 1, I'll wire the XOR gate so that its output becomes A. With that setup, the initial values of A and B are both 0, so at first, nothing happens. When B is switched to 1, the output becomes 1, so A changes to 1 as well. Now, both A and B are 1, which makes the output return to 0, and this keeps alternating. The loop continues as long as B remains 1. Once B becomes 0, the output will match the value of A, whether A is 0 or 1, so the loop stops. In theory, everything should work perfectly. However, in practice, this does not behave correctly.
It appears to work fine the first time it operates. But when it runs again, a malfunction occurs. This issue happens because signals accumulate in places where we can't see them. It seems to operate normally the first time, but when B is switched back to 0 again, the circuit malfunctions. This happens because a new signal is added before the previous 1 signal has fully disappeared, causing the signals to overlap. To solve this problem, we need a function that can cut off the signal. However, functions 1 and 2 obviously can't do that. Functions 3 and 4, which only send and receive signals, also can't interrupt them. Shoot gates and touch gates are not capable of cutting signals either, and the same goes for monitors and cameras. We already confirmed that the logic gates we tested earlier also cannot fully block the signal. So the answer is clear. Only function 5, force, can interrupt the signal. The force function, option 5, consists of 6 variations, but discussing all of them would be complicated, so we will focus only on positive when activated. This function outputs a high signal 1 only when it is activated. So you might wonder, how does that allow us to cut off a signal? The key is that this function does not output any signal when it is deactivated 0. Because of this hidden behavior, when we combine it with logic gates, we can control the signal, either passing it through or cutting it off whenever we want. In the device shown on the screen, the XOR output is routed through P instead of being sent directly back to A, and a force function is added to the logic gate. As a result, when the XOR output becomes 0, the signal is blocked, allowing the circuit to reset and operate correctly again. However, in actual operation, we can see that it loops when B is 0 and stops when B is 1. I'm not sure why this happens either.